there should be an envelope for you. The sign-up schedule for retakes is in the office. On Monday after school, today and Monday. Sign up outside of class only. Could McKenna Brar please come to the office for a pickup at lunch? And there will be a trades open house next Wednesday, March 4th from 4 to 7 p.m. at the Trades and Technology Center in Chilliwack. RSVP at ufb.ca/visit-TTC. The following students need to report to PAC today at luncheon room A209. Jason Doward, Simran Bola, Jovan Malay, Jaskaran Chima, Blake Fonseca, and Blair Collins. Have a great day, Panthers. Now back to learning.
Now, this one here, technically, that should move to the front, shouldn't it? Because that x cubed is the biggest, yes? Right? And when we move that x cubed to the front, I end up with a negative coefficient at the beginning, yes? And normally we don't like that, so we would bring that negative out. Does everybody understand? I don't care. I just want you to see that some people might be that male sexual organish enough to make you do that. Okay? 22x squared x plus 3y. Check your work. Make sure you're doing it right. Any questions on those four? This is being recorded, so you can go back and write them down later. If you didn't do your work, don't bother writing it down now. That's what I gave you 40 minutes yesterday for, and overnight. Factor this equation. Now, a lot of kids say, how can I factor it? There's no numbers. Doesn't matter if there's no numbers. What math is happening between pi and r? Multiplication. What's happening between pi, r, and s? Multiplication. So pi is in both of them, isn't it? R is in both of them, isn't it? So that means the greatest common factor is pi r. And what does that leave? R plus s. Find the surface area if the radius is 5 and the slant height, which is obviously s, is 2. That is pi times 5, because that's r, times 5 plus 2, which is pi times 5 times 7, which is 35 pi. And those of you who have been paying attention so far know that that is how you will finish all questions with pi now. You will not do 35 times 3.14. You will not do 35 times the pi button on your calculator. That is where a question with pi ends. Okay? We're going to do a whole unit on that type of stuff coming up. And that was that. And then, because people didn't do so hot on it, I also wanted you to do 4 multiplications. So, can I do the little shortcut here? Yes. I can, but a bunch of you didn't do that very well on the assignment I gave you. So, of course, I'm going to do the long way. X times x, x squared. X times 5, positive 5x. Negative 3 times x, negative 3x, and I stack the x's together so I can't screw it up, negative 15. And then my answer is x squared, 5 minus 3 is positive 2x minus 15. This one, 6x squared minus 8xy. This one, again, I could do the shortcut, but I'm not gonna. X squared plus 4x plus 2x plus 8 all equals x squared plus 6x plus 8. And finally, x squared minus 2x minus 4x plus 8. X squared minus 6x plus 8. Everybody needs to be able to do what we have done on GCF factoring and must be able to multiply effectively before I go forward. I know that you are not going to tell me if you cannot, because it will embarrass you. For some strange reason, you think that not being able to do something in math class is a bad thing, even though most of your peers have trouble with most of the stuff you are doing. That's okay. You don't need to say it out loud, but you need to know if you are having trouble with GCF and with multiplication. And if you are having trouble with that, you must rectify that situation. How do you rectify that situation? One, you go and ask a friend. Because if your friend can do it, obviously they understood somebody teaching it to them, and maybe they can put it in words you understand. If that doesn't work, you come and see me quietly, privately, so you don't need to be embarrassed about anything. Pace, hit me. Why is the GCF of which one? This one? Why is it 8? Because 8 is the only number that goes into 24, 16, and 56. Pardon me? Yeah, but GCF stands for what number? Or what letter? Is 8 greater than 4? Okay. So, if you did 4, right? Then you would have had 4c, right? And then you would have had 6c squared minus 4d squared plus 14cd4, yes? And then, of course, you would have noticed 6, 4, and 14 all divide by 2, don't they? So then you would have brought out another 2. And when you bring that 2 out there, there's already a 4. And just like in radicals, what do coefficients do? So I would get 8c outside. Okay? Everybody understands that? That's a good question. Because sometimes you think you're done. Because you factored, didn't you? You brought out a 4. I factored. Now let me ask you this. What can I give you as credit for that? Did you factor? Class, did he? Okay. So if I were to put up the descriptions of the 1, 2, 3, 4, right? If I were to put them up, their headings nowadays are emerging, developing, proficient, and extended. What would you call that? You would call that proficient? I would call it emerging, because he knew to divide out something, right? Right? Everybody with me? Now let's say he did all the rest of them correctly. Then I would be leaning towards proficient. Everybody understand? Everybody cool? Right? And I'm not trying to put you on the spot, of course. I'm just trying to explain how I would look at this. Because it's not nothing, right? I wouldn't do the grade 3 wrong and give you no credit for it. But by the same token, I couldn't give you full credit for it, right? Everybody understand? Okay. Now, what if he said that these highlighted numbers were 12, 8, and 28, and he brought out a 4? Then what would I have to give him? I'd have to give him a significantly less than even emerging, right? Like that's developing, because he knew something had to come out, but it made no sense. Everybody understand? And of course, leaving it blank is 0. All right. And we are all good with multiplying? Even if you don't remember the little fancy shortcut, you can always double distribute, right? Or some cases, triple distribute. All right. So that is factoring type 1. When do we do GCF factoring? Every chance you get. It's written in giant purple fake ink on the notes, right? Every chance you get, you do a GCF. Everybody cool? Okay, so that's the first type of factoring. Let's move on to the second type of factoring. Now, ladies and gentlemen, you know how I usually make sure to tell you why something works and not give you just, this is what you do, right? Okay. This is one of those rare times that you already know what to do with this when we factor it. You're going to know. And you're going to be like, oh, okay. And if I show you why, or when I show you why, you'll be like, ugh. All right? So, before we get going forward, we got to identify some stuff here. Are these factors or products? They are factors. How do you know that, Mandra? Because a product is an answer. Okay. Is there any operation written between the two polynomials? There's no one written there. So when it's not written, what is it? Multiply. So since these two things are multiplying, they are factors. Now often, kids have a lot of trouble with understanding how this could be a factor when it's got two terms. It's a binomial, isn't it? How can it be a single factor? Well, if I told you that x was 6, then what number is that? 10. And it would be a single thing, wouldn't it? Does everybody understand this? So even though that is two terms, it is grouped together as one factor. Because if I told you that x was 6, then this would be 10, this would be 12, and the product would be 120, wouldn't it? Does everybody agree? So I'm just going to write that. If x equaled 6, then I have 6 plus 4 times 6 plus 6 to get 120. Everyone agrees, right? 6 plus 4 is 10, 6 plus 6 is 12, 12 times 10 is 120. Yes? Okay. But I don't know what x is, so I have to distribute. Now, your 9th grade teacher, if you did it, called this FOIL. I don't like calling it that because it only works with binomial. So I'm just going to say I'm going to distribute. What will this x hit first? The other x, and I will get x squared, won't I? Yes? And then what will it hit? The 6x, and then the 4x, and then 6 times 4 is 24. And I will get x squared plus 10x plus 24. Agreed? Right? Okay. Now, if x is 6, what's 6 squared? 36. What's 10 times 6? What's 36 plus 60? 96. What's 96 plus 24? 120. And I get the same answers. Everybody cool? Okay. That is factor 1. That is factor 2. That is my product. Everybody good? Now, we've already spent a lot of time talking about this. There's no number in front of the x, is there? What's the relationship between 4 and 6 and 10? They add to get 10, don't they? What is the relationship between 4 and 6 and 24? That one's multiply, yes? So, if we are faced with this trinomial, x squared plus bx, some number there, plus c, just like what we have here, right? X squared bx plus c, right? If you are to factor that, it's going to go back to this. Will it always go back to that, do you think? Do you think it is always possible to factor one of these things? No, it is not. So you need to be careful. But if it does factor, you know that this is going to break down into x and x, isn't it? To make x squared, yes? And then I'm going to need two more numbers there, yeah? Well, what do those two numbers have to do? They have to satisfy two conditions. What are those two conditions? They must add to 10 and multiply to 24, yes? So that's how we're doing it for this one. But what will we do for this one? What must these numbers do? This is not a 10. What must these numbers do? Add to what? In this case, it was 10. What is it here? B. I need numbers that will add to B and multiply to what? C. How many numbers do I need? 2. So it's not a factor tree, it's pairs of factors. Everybody understand? And then you just check if you've done it right. Is this still that unit where I said you never have to ask if you did it right? Yes, because you can check. Is 4 plus 6 10? Is 4 times 6 24? Yes. So we're good, right? Now the only thing that messes kids up is whether these are positive or negative, right? So there's 4 options, right? I could have x squared plus bx plus c, right? What's the second option I could have? X squared minus bx minus c. What's the third option I could have? X squared plus bx minus c. And the fourth option? X squared minus bx plus c. Yes? Now, you're intelligent young people. When they're both positive, what type of numbers add together to make a positive number and multiply together to make a positive number? They must be two positives. So this would be x plus m and x plus n. They'd both be positive, yes? What multiplies together to make a negative number? A negative and a positive, yes? So this would be x minus m, x minus n, plus n, right? What about the blue one? Would it be the same? Yeah, it's still going to have to be a minus and a positive, isn't it? And what about the green one? Tricky. What will multiply to a positive but add to a negative? 2 negatives. Now, without actually doing any factoring, you all already know the format that every answer is going to take, don't you? So all you have to do is come up with 2 numbers that multiply to the C and add to the B. That's it. Everybody cool? Well, let's look at this first one. Which of these is this? It's the blue one, isn't it? So I know that this is going to be x plus and x minus, right? I know it. It has to be. Because how else could I get a negative 18? right? So now all I have to do is decide on two numbers that add to what? 7 and multiply to what? Multiply. You just got to say 18, and I'll tell you why in a sec. Will 1 and 18 add together in any way to make 7? No, so it can't be 1 and 18, can it? Will 2 and 9 add together in any way to make 7? How? 9 minus 2, right? Positive 9 minus 2. Hey, positive 9 minus 2. And then I check. X times x is x squared. Negative 2 plus 9 is positive 7. 9 times negative 2 is negative 18. Does everyone see how easy this is? Does anybody have a question? It's pretty simple, yeah? So let's look at this one. It's negative, negative. So, what do I automatically know? It's the red one, right? So it's going to be x minus x plus, yeah? And what do I know about the numbers that are going to go in there? They have to do two things. What are they? Add to negative 2 and multiply to negative 8. Is it 1 and 8? Can 1 and 8 make negative 2 in any way? Is it 2 and 4? How? Negative 2 and positive 4 makes negative 2. Negative 4 and positive 2. Hey, negative 4, positive 2. Now, I did promise you I'd show you why we do it this way. If you were here on Wednesday when we did this with the actual algebra tiles, remember how hard it was to do this one if we didn't start on the ends, right? That's why we do this. Because we know that this number has to multiply to 7. That's where all the options are, isn't it? Right? So when we go to what we're working on right now, we know this last two number could be 1 and 8 or 2 and 4. This number tells us which pair we're going to use so we can fill up the rectangle. Is everybody good? All right. Look at the next one. Figure it out. Go. What color from the top would I be using? Green one, because it's positive and negative. X minus, X minus. What are the numbers that add to 12 and multiply to 35? 7 and 5. And since they're both negative, I don't even have to think about it. Done. Now listen, please. Some of you, a lot of you, are going to feel that you don't know what you're doing or you can't do this because some kids find that pair very, very quickly. Does that mean you don't know what you're doing? Of course not. That's like saying you don't know how to run because someone else runs faster than you. Everybody understand what I am saying? And that is also why the people that get the answers a lot need to tone it down a little bit. Okay? Abby.
What is the x? Like, do you not do anything with the x besides the 12?
When you expand this, what's going to happen? What's x times x?
X squared.
What's x times 5?
5x.
5x. What's 7 times x?
7.
Negative 7x. There's your x by the 12. Because factoring is the reverse of expansion. Does everybody understand? Everybody? Awesome. Do D. I changed the letter because nothing bothers me more than when kids say, I could do A, B, and C, but I can't do D. Why? Because it's not an X. Is that an excuse I ever want to hear? No. So, I know that's negative, so I know that this is A plus and A minus. What do I need to multiply to? Or add to? And multiply to?
20.
Negative 20. Is it 1 and 20?
No.
Is it 2 and 10?
Yeah. No. Yes.
You can't just keep saying yes and no to yes-no questions. Is it 2 and 10? No, it isn't, is it? Because how will 2 and 10 multiply to negative 20? It would have to be negative 2 and positive 10, yes? So kids come over here and they say, okay, I see positive 10, negative 2, done. Are you?
No.
Why not?
Because positive 10 minus 2 isn't 12.
It won't make 12. So some kid says, okay, wise ass Myers, you're not fooling me. It's positive 2 and it's minus 10. Ha ha, got you. Do you? No. So if 10 and 2 doesn't work, do 4 and 5. So if there are no factors of 20 that add to 12, can I factor this? No. It's done. It's just like saying when you have finished simplifying a fraction and you get to 6 over 19. Is that fraction done? Yeah. This is done. You cannot factor it. So all you do is you tell me it doesn't factor. It's done. Now, what if you leave it blank? Does that show me you know anything? No, you have to give me an answer. If it doesn't factor, you say doesn't factor. I'm going to warn you. You will get some of them on quizzes, tests, and assignments because it is just important to know when you can't do math as it is to know when you can. Right? Everybody cool? Okay, notice right here, we have a quiz. We're not doing that today. We'll do that sometime after today. Now, you all can do E by yourself. Do it. Page 64, do E. I can't do it, Mr. Myers. It's not an X. Yes, you can. Be strong. When you're done, tug on your right ear with your left hand. It's always funny when I do that because I see every kid do this. And then they go there. All right, who would like to tell me the answer? Abby Berg.
Y minus 7 and y plus 2.
Y minus 7 and y plus 2. How many people agree? All of you, because you can check it, can't you? Is negative 7 plus 2 negative 5? Is negative 7 times 2 negative 14? So did Abby do it right? Right. Look at F. What bothers you? There's a 4 there. Right? We don't want that 4 there, do we? What math is that 4 doing right now? Multiply. What math would get rid of multiply? But if I divide the first thing by 4, I better be able to divide everything by 4, right? Can I? Yes, because this is a GCF first question, isn't it? What is the GCF? 4. So what comes to the front? 4. What stays in there? X squared minus 5x 14. Hey, we just factored that, didn't we? So what is this answer? It's 4. And then that, except it wouldn't be y's, would it? What would it be? X's. Everybody good? Is everybody good? Now, is this right? X plus 2, x minus 7. Is that right? You sure? You're sure?
I think so.
That's not sure. How could you check? Is 2 minus 7 negative 5? Is 2 times negative 7 negative 14? So is that the right answer? So are you sure?
Yep.
So don't be a wuss. Be sure. Because you can check it, right? Is this the right answer? X minus 2, x plus 7. Is that the right answer? No. Why?
Because it has to be negative.
Because negative 2 plus 7 isn't negative 5, so that would be wrong. So does the plus and minus matter?
Yes.
Yes. Doesn't matter which one goes first, but you have to have the right factor with the right sign. Everybody cool? All right, what bugs you about G?
A 10.
The 10. So what are we going to do with it?
Divide.
We're going to factor it out, just like Mr. Myers taught us. So 10 is going to be at the front, and then what's going to be in the middle?
8x.
X squared plus 8x plus 12. Now I need numbers that multiply to what?
8 and
12 and add to what? What are they? Don't say it out loud. Let somebody else think it out. Positive, positive, so it's x plus, now what? 6 and 2. Mr. Myers, did I do this right? Did I do this right? Check my work for me. Check my work for me. No, kid, because 6 plus 2 is 8 and 6 times 2 is 12. You already know it. Everybody good? What bothers you about H?
-4.
Now, this is one of those weird ones, isn't it? Because the greatest common factor here is positive 4, isn't it? But we don't like that negative there either. So what will we take out? Negative 4. Which then messes me up in here. What's negative 4 divided by negative 4? Positive t squared. What's negative 16 divided by negative 4?
14.
Positive 4t. And what's 128 divided by 4? You may need your calculator for that, but I'll help you out. It's negative 32. Now, I would need numbers that multiply to what?
4.
Nope.
Oh, 32.
Multiply to negative 32 and add to what? 4. What are they? Negative 8 and positive 4. Negative 8 and positive 4? Is negative 8 plus 4 positive 4? Negative 4 positive 8, right? Now, let's say he writes it down backwards. But he did this right, and it is 8 and 4, isn't it? Developing, emerging, proficient, what is it? What do you think? Reflect on this. Developing is the bottom. Or no, developing is second level. Emerging is the beginning. Is he developing? He's obviously not emerging, right? He brought out the 4 and he knew it was 8 and 4. He's well past emerging, right? Is he well past developing? Or is he right in the middle of developing? He's right in the middle of developing until I said negative 8 and 4, and then he fixed it. So is he approaching proficiency?
I believe so.
Everybody understand? That's possibly by the end of your high school careers, that's what your report cards are going to look like. So I want to talk about it as much as we can. All right? Okay. So Gerner has changed his mind. It is -4 and +8. T plus 8. T minus 4. Dun, dun, dun. Now, please notice that changing the looks of these has meant no different math, hasn't it? Right? It hasn't changed the math. So we're allowed to change the way it looks, aren't we? What bothers us about I? It's written in the wrong order, isn't it? Can I change that order? Could I do -d squared minus 5d minus 24? Is that okay? Of course it is, because they're all still negative, yes? I have the exact same things, right? Now what bothers you? A negative at the front. How do we get rid of that? We divide by -1, yeah? So I'm going to have a negative at the front, and then I'm going to have d squared. What happens here? Positive 5d, and what happens here? Positive 24, right? Are there numbers that multiply to positive 24 and add to 5? There's not. You want to say 8 and 3, don't you? Right? But can we say 8 and 3? No. Why not, Julius? Yeah, I know. Why not? Well, you shook your head. You must have a reason. Why can't I use 8 and 3? Because 8 and 3 multiplies to 24, doesn't it? Does it add to 5? No. Because it would have to be positive 8 and positive 3, yes? Could it be -8, -3? That would still get me positive 24, but would it get me positive 5? No. So guess what? That's done. We took out the only factor we could. We tried something to make it look more factorable. It didn't work, so we leave it. Everybody good? All right. Tell me what's different about J. And nobody say it's that I used a V instead of an X.
There's two variables.
Right. There's two variables. Okay? Now, how many times have I said in this class, if you can do it once, you can do it every time, yes? So, if this letter J was back up at B, it would look like this, wouldn't it? Right? And you would all know what to do, wouldn't you? You would need numbers that multiplied to what and added to what? Multiplied to -20 and add to 19. Is it 1 and 20? It is, isn't it? Right? How do I get 1 and 20 to give me 19? 20 minus 1, yes? So the answer would be V plus 20 and V minus 1, correct? Does everyone agree? V times V, V squared, right? What's the only thing missing? I need a B there. Because 20B times 1B is 20B squared. Kids look at that and they say, oh my God, I can't do it. What do I do with that extra letter? And why is that a problem? You know that V times V gives you V squared. So what gives you B squared? B times B, right? So look at K. Is K a problem? No, because it's going to be just X plus or minus something. What? What am I going to need in the second term of each binomial? A Y. Why will I need that Y? Because I need to make a Y squared, yes? So I can look at this and I can say to myself, self, I don't need that y there. I need numbers that multiply to 28 and add to 12. Negative 28. What are they? 14 minus 2, right? X plus 14. What? Y. X minus 2y. Right? Everybody with me? L asks you to put it all together. What bothers you about L?
There's no number to add to.
Sure there is. There's a number there that we don't write. What is it?
1.
So there is a number there to add to. What is something else that bothers you about L? Abby, go again.
There's 3 B's. Like
There's 3 B's there. We know what to do when there's 2, but what do we do when there's 3? Well, we would look and we'd say, all right, Myers said the first thing we should try is GCF. Is there a GCF here? What is it? B, because there's 1 B there, 2 B's there, and 3 B's there. So there's B's all the way through, isn't there? I hope nobody has anaphylaxis. Allergic to bees? Nothing? Nothing? Divide by B. The B goes to the front. Now, half of you are going to not write that B at the front. Do I need that B at the front? Yes. Half of you are going to forget it. And that's the type of thing that is going to keep you at the proficient level, not the extended level. Everybody understand? That's the difference between, 85 and 90. Picking up what I'm putting down? All right. Then what's this going to be in here? A squared
minus 1
AB minus
20b cubed.
20b squared. And now I need numbers that multiply to negative 20 and add to negative 1. Is it 1 and 20? Will 1 and 20 get to negative 1 in any way? How? No. Will 2 and 10? No. Will 4 and 5?
Yes.
How?
Negative 4 plus
4 minus 5 is negative 1, right? So this must be A plus 4B and A minus 5B. I need to stop there for a moment because the next two things are really weird. I need everybody to be okay right now. Are you at least at emerging? You're all cool, right? Okay. You've seen this unit or this section already. We have taken something that we could do really easily and we've applied it to things that look different, yes? Right? Okay. You should have noticed that every single first term was squared, yes? And when we factored it, we ended up with the square root, didn't we? So look at M. M looks different, right? But it also looks kind of the same, yeah? Is it a trinomial? Yeah. Does the leading term have a coefficient? Is there a coefficient in the middle? Is there a constant at the end? So it looks very similar, doesn't it? So even though it's different, let's apply some knowledge that we already have. We have just done 12 questions where the first term of the answer was the square root of that. Should we try that here? Does it make sense to try it here? You've just done something 12 times in math and seen it repeat. Is it safe to assume that we could do it again?
Yeah.
Let's try. That would give me x squared and x squared, yes? If this said 2 and this was 1, it would be x and x, wouldn't it? Okay. So then multiply to 50, add to negative 15. What is it?
Negative 5,
Negative 5, negative
negative 10.
10, right? Negative 5, negative 10. Is x times x, x squared times x squared, x to the fourth? Is negative 10x squared and negative 5 more x squared, negative 15x squared? Is negative 5 times negative 10 positive 50? And see how you can solve stuff without actually having been taught that exact question. You bring your prior knowledge to the party, yes? Now what's weird about n?
0.
I need numbers that multiply to what? Negative 9 and add to what? 0. Huh. Is it 1 and 9? So what is it? It's got to be 3 and 3, doesn't it? X plus 3, x minus 3. Now, why would I write that? Would we ever write that? What should this trinomial really be? X squared minus 9. Keep that in your head. All right? Some of you already see the pattern there. Oh no, I've done it again in O. What should that really be? X squared minus 625. You're smart kids. X squared 0 minus 9, x squared minus 9, x3, x3. What's this one going to be? Without even thinking about it. X plus 25, x minus 25. What would this one be? X squared minus 16. X plus 4, x minus 4. What would this one be? X squared minus 49. X plus 7, x minus 7. What's the pattern? Square root, right? And lastly, from me today, because the next thing you'll be doing by yourself, what do I need? Numbers that multiply to what? 16 and add to what? What is it? X plus 4. X plus 4. Please notice there's something special here. What do you notice? 16, 4, 4. It was a perfect square. And they added to the middle still, right? Would we write this like this? How would we write this better? No. X plus 4 squared. The whole thing. Everybody good? All right. Edward.
Why would you find multiple 16?
Because 16 is in that spot, the same way we've done for the previous 18 questions. We've always found multiples of the C term. Right? Okay. And it can't be 1 and 16. It can't be 2 and 8. It has to be 4 and 4. Your homework, page 65 and 66. And we have a quiz Monday. All right? Everybody good? 65 and 66. And Nino, you're in charge.
Oh, for once? Oh, thank you. Okay, guys, we're changing all the laws. Okay? Well, we need to vote.
Nino, any smart ruler has secret police. Be careful.
It's not a secret when you say rules. Yeah, no, but I need to say if you want to switch it. No, I don't get it. It makes no sense. No, you know.
Did someone just get up and leave?
I didn't even need secret police. I left the room bugged. Just kidding. I don't ever watch the videos.